Hi everyone. Good morning, guys. Very good morning, all of you. Hope you're all doing well. Is audio and video both are clear, everyone, all of you? Audio and video both are clear, all of you? Somebody? Right. So here, clear, everyone? Right. Yeah, Rishikesh, your class is started. Yes, Deepak, good morning. Rishikesh, good morning. Yes, class is just started, right? Yeah, no coffee, only milk. Right. So this which one will be doing with you can say this is a highway quick revision series we are doing, right? So all of you had your tea, coffee, hot water, juice, breakfast, everything you had or not? All of you. Tea, coffee, hot water, juice, breakfast, everything over or not? This highway quick revision series will be continuing, you can say, all of you. Welcome to Unacademy. Let's crack it, right? Everyone get ready to crack. All of you are ready to crack or not? Right. So what is that referral code you have to use? Right. RP Civil is the referral code you have to use. So this is my profile, you can follow me at which. If not following, start following. This is the referral code you have to use and you have to recommend it to all your friends, juniors and everybody. Those who are willing to take their subscription, right? For the plus and iconic subscriptions in Unacademy, okay? So this is GATE 2024 AIR1, right? 7 AIR1s we are having. This is Ummeed batch. It was started yesterday at 5 p.m. by Jaspal sir. You can say. And what is it? A referral code you have to use, right? RP Civil is the code you have to use, na? RP Civil is the code you have to use, right? Sangram batch for this GATE ESC PSUs. It also started on which one? This March 30th for 2026 aspirants. And today will be the last date, right? Today will be the last date for availing this offer, right? This 1 year plus subscription at which one? This is a 19,999 rupees, right? So don't miss this. Inform to all your friends. So from 1st April onwards, the prices are going to be raised by 30%, right? Don't miss this opportunity, everyone. These placement batches also will be starting on which one? This is 30th March. They have started, all of you. So these are all the books you'll be getting printed to your printed books delivered to your home within 15 days of your subscription, and when you are taking iconic subscription only, right? Not for plus. This no cost EMI option will be there and 0% interest on loan will be there available. Don't miss this opportunity. So these are all plus subscription features. Along with the plus subscription features, right? These are the additional features of iconic subscription, you can say. Okay. Now, so coming to this, right? What is that we have discussed? If you remember, that highway materials, right? Soil test we have discussed now. So if you just remember, right? If I'm not wrong, so which test gets over? You can say this is soil test gets over now. This is soil test gets over or not? Highway materials, that is soil. So soil test, right? In this soil test also, which test we have done, right? That CBR test we have done and a plate load test we have done, right? Isn't it? This is 153 point. Up to this we have completed. Now we'll be starting this like lecture 12, right? Quick revision lecture 12 on this highway engineering. Aggregates will be discussing. Okay, aggregates will be discussing, you can see. So this is your which one? Second slide. Highway materials aggregates will be discussing. Now coming to this, right? What are these aggregates? Tell me if you just know that aggregates will be what? Aggregates will be useful for which purpose? Various purposes, na? Main strength contributing elements are which one? Which one are the main strength contributing elements in your main strength contributing elements in your bituminous mix? Tell me. Aggregates are only main strength contributing elements, na? Is that no? Without these aggregates, do you get strength to the bituminous mix or you don't get strength to the bituminous mix? Tell me. You do not get strength to the bituminous mix without these aggregates or not? Yes, right? Strength, mainly that strength parameter, right? Strength is mainly given by which one? These aggregates only. So aggregates are crucial elements, now very important elements, you can say it or not? Yes, very important elements, you can say, right? You cannot neglect these elements, right? Now coming to this, right? First of all, what is that aggregate impact value? How can you get that aggregate impact value if you just observe AIV? How can you calculate that? That AIV will be equal to how much? After testing is done, right, we have to consider which one is that weight passing, na? Weight passing this 2.36 mm sieve divided by which one? Original weight or this total weight, na? So no, original weight or this total weight into which one? This 100, right? So suppose, yeah, Pravalika, namaste. So suppose if this aggregate impact value will be higher, what it will result in? Aggregate impact value is higher means, right, that toughness will be higher or this toughness will be lesser, tell me. Aggregate impact value is higher means you can say that toughness will be automatically lesser, na? So no, toughness will be automatically lesser, you can say if you just right, isn't it? Toughness will be automatically which one? This is lesser if you just right, isn't it? Toughness less, aggregate impact value is higher means more weight is passing, na? More weight is passing means, right, more loss will be there, na? More damage happened or not? More damage happened, right? So now tell me, what is that total impact energy used in this aggregate impact value, tell me? Those are missed. Total impact. Total impact I am writing. Yes, I'm good. Total impact energy. What is the total impact energy we are using in this test? Tell me. What is the total impact energy we are using? Here, we will be falling it from how much height? If we just observe, this hammer will be falling from how much height? Tell me, everyone. This hammer will be falling from how much height? All of you. Anyone? This hammer weight will be 13.5 to this 14 kg will be there. It is falling from how much height? Everyone, others. Falling from which height? Falling from which height? 38 centimeters, right? 38 centimeters. You have to be very, very careful, right? 38 centimeter, right? Falling from this 38 centimeters, right? You have to be very, very careful, right? It is falling from this 38 centimeter. And how many blows we have to apply totally? That is your 15 blows we have to apply, na? Yes or no? 15 blows we have to apply, you can say, right? So what is the total impact energy you come across then now? What is the total impact energy you come across now? The total impact energy is equal to 15 blows. For each blow 14 kg into which one? This is 38 centimeter falling, right? So now how much it comes to be if you just observe? That is your 7980 kg centimeters, na? 7980 kg centimeters is the total impact energy you are having or not? That is your total impact energy, you can say, right? Now tell me. So what are these? We have to allow any aggregate impact value or we have to restrict this aggregate impact value? Tell me. Is it okay to allow any of these values or we have to restrict it compulsorily? We have to restrict compulsorily. Yes or no? We have to restrict compulsorily. So what are these? You can say limits of what? Limits of this aggregate impact value as per which one? As per this IRC, right? What is that? You can say that aggregate impact value should not be greater than 30%. Na? So for aggregates in which course, which layer? Tell me. For aggregates in which one? Wearing course or this surface course? Na? What is the meaning of this wearing course or this surface course? Tell me. That wearing course or this surface course is nothing but it is your topmost layer or not? If you just observe, that is your topmost layer, you can say. And it should not be greater than which one? This 35% for which one? Aggregates in which layer? Bituminous macadam. Bituminous macadam of which one? This BC, right? What is the BC? Base course, right? And it should not be greater than which one? This 40% for what? Whenever you are using the aggregates in which one? This water bound macadam, right? Whenever you are using it in this water bound macadam of which one? base course only, right? What is the BC? You can say that BC is nothing but your base course, right? Okay, BC is nothing but your base course, you can say. Got it? Clear? Once clear, now done. Once want to tell me Rafa, this one. Done. Right, everyone done? So here now, so what are the other values, right? So this is about your aggregate impact test, right? So what is that next test we'll be having if you just observe? Aggregate crushing test. No? This is your fourth slide. Okay, fourth slide. This is fourth one. So aggregate crushing value, right? How can you get this aggregate crushing value? Tell me if you just observe. ACV. So what is that aggregate crushing value we'll be getting if you just observe? How can you get that aggregate crushing value? That aggregate crushing value ACV will be equal to same after this weight passing that 2.36 mm sieve only, no? Weight passing that 2.36 mm sieve divided by what? Initial total weight taken, no? So no, that is your initial total weight taken into that 100, right? Now suppose if the aggregate crushing value will be higher, so aggregate impact value, impact test is measuring the toughness, but this crushing test is measuring the strength. Na? When aggregate crushing value is higher, what happens? Tell me that weight passing 2.36 mm is higher, right? What does it mean? It means that more material is damaged. Na? More material got damaged means the strength will be higher or the strength will be lesser. If you just observe that strength will be obviously lesser. Na? Strength will be obviously lesser, you can say, right? So what is that ACV aggregate crushing value? Should not be greater than this 30% for what? For aggregates in surface course SC, right? So previously that is surface course SC, we can write it, right? So surface course aggregates in surface course, right? It should not be greater than which one? This is 45% for which one? Aggregates in base course, right? BC is nothing but your base course, you can say, right? Got it? Now, so what are the specifications? Aggregate crushing strength, right? What is that? Aggregate crushing strength. For this aggregate crushing strength, if you just observe, what is that rate of loading? Anyone having idea, right? What is the rate of loading? That is rate of loading is nothing but your 4 tons per minute, na? 4 tons per minute. For how much we'll be applying? For 10 minutes we'll be applying. So for 10 minutes applied, na? For 10 minutes only we have to apply this, you can say. Then what is the total load it comes to be if you just observe? What is the total load it comes to be? For every minute it is 4 tons, means right, 10 into 4, how much it comes to be? That is your 40 tons if you just observe, right? That is your 40 tons, you can say, right, like that. Is that clear? Aggregate crushing test, aggregate crushing value, is that? This is strength test. Next, coming to this area, I'm writing 1, 2, 3, na? Okay, 153 got here. This is your 154. Okay, I forgot I'm writing like that. Okay, 155, 156. Okay, one 57. This is 158 and 159. Okay, right. Next, 160th point. What is the 160th point? If you just observe Los Angeles aberration value, if you just observe What is it we have to go for it? Los Angeles aberration value na. So now what is it Los Angeles aberration value? How much it comes to be if you just observe? You remember this drum will be there and this drum will be rotating na. So now this drum will be rotating, right? So now here what is that you are having inside this drum? So these aggregate particles will be there, and after the test is over, it will be collecting this and will be passing through 1.7 mm. So along with that aggregate side, which one will be there? You can say that a steel balls will be there now. Some steel balls will be there and these aggregates will be there, right? So now how can you get that a Los Angeles aberration value if you just observe? That after this testing is over, at a Los Angeles aberration value will be how much you can say? Los Angeles aberration value will be what? Weight passing which is you, is it 2.36 mmcu or it is your 1.7 mmcu? Weight passing this 1.7 mmcu na? Yes or no? You have to be careful. Weight passing that 1.7 mmcu divided by what? That total weight into how much it comes to be? Into that 100 na? Yes or no? Into that 100. No. What is it you can say? That a Los Angeles aberration value should be higher or it should be lesser? It should not be greater than which one? 16% for aggregates in what? This is for aggregates in which one? This is cement concrete. Okay. Okay, carry on. Deepak. So this is in case of this is cement concrete, right? In case of this is cement concrete, if you are using these aggregates now, then the Los Angeles aberration value should not be greater than which one? This is 16%, right? And it should not be greater than 30% for which one? For aggregates in what? For aggregates in surface cores of this bituminous mix, right? For aggregates in surface cores of which one? This is a bituminous mix, right? Yes, Dev, good morning. Yeah, Deepak is going and Dev is coming. Both will not come together, right? And it should not be greater than which one? This is a 50%. For aggregates used in which one? This is a base course. Okay, for aggregates used in which one? You can say base course of bituminous bound macadam. Next, 162. Who are you? Who is that fellow? Yeah, nobody knows about that fellow, right? So what is it? Los Angeles aberration value. That Los Angeles aberration value is a measure of which parameters? Tell me. Is a measure of which parameters? If you just observe attrition. What is the meaning of attrition? Tell me. Okay, you are completing everything. Attrition, right? What is the meaning of this attrition? You can say attrition means it is a rubbing action between. Yeah, here actually I forgot to write that. Los Angeles aberration value is higher means what will happen to this hardness? Tell me. Hardness will be lesser, na? Los Angeles aberration value is higher means that hardness will be lesser, obviously, or not? It is a measure of hardness, right? Yes. Attrition, what is that attrition? It is a attrition is nothing but your rubbing action between particles of same nature or different nature. Attrition is the rubbing action between particles of this same nature. Na? Next, aberration, what is that aberration? You can say it is a rubbing action between particles of same nature or different nature. Aberration is different nature, right? Yes, no? Now, third one, impact. So those steel balls and these aggregates rubbing action will be there, that is aberration. Aggregate to aggregate rubbing, that is attrition. Next, impact. How is that impact comes into picture? Tell me. So whenever this drum is rotating like this, right? So these steel balls and aggregates will go up to certain point and they will fall suddenly onto the bottom aggregates. Is not? So that is why it is a measure of which one this impact or not. Yes, it is a measure of this impact. You can say we just observe, right? Got it? No. Clear? Note this and tell me, everyone. This is only your short notes, right? You need from this only you can prepare these short notes. You write whatever I am writing. That's it, is na? So Your work also I am only doing. Is na revision, how to do the revision and how to prepare the short notes and all are doing. I am only doing all for you. But utilize this, right? Utilize this and make use of it, right? I am putting this much effort, and if you are not utilizing, it is of no use, na? Yes or no? You have to utilize it, right? That is very important. Don't be lazy this time also, okay? What to write, what not to write, you will be having confusions, na? For that, for avoiding those confusions only, I am taking this revision series and like that. Yeah. So in Los Angeles. So in this Los Angeles aberration test, right, what is the speed we have to go for? Tell me. What is the speed of this rotation? This is your 32, which one? This is 33 RPM, right? What is that RPM? You can say rotations per minute, na? And how many number of revolutions we have to go for? What is the total number of these revolutions we have to go for? Tell me. The total number of revolutions will be 500 to which one? This is 1000, 1500 also we can go up to 1000 to which one? This 500 to this 1500. These are based on which criteria if you just observe? Based on what? Gradation of particles, na? Yes or no? Based on this gradation of which one? These particles, right? Gradation of these aggregates, right? Right. Gradation of these aggregates used, right? What is the meaning of this gradation? Tell me. Gradation is nothing but it is your particle size distribution or not? Gradation is nothing but, yes, gradation is nothing but your particle size distribution, you can say. Now, next one, what is the coefficient of hardness? If you just observe, how can you get from this? Coefficient of hardness is equal to 20 minus what? Loss of weight in grams. G means grams, divided by which one? This 3, you can say it, divided by this 3, right? Now, so what is the specific gravity of this aggregate? Tell me. The specific gravity will be varying from which one? Generally, this is 2.62. 2.62, which one? This is 2.9 for what? 2.62, 2.9 for which one? This is good road aggregates, na? Good road aggregates, right? Next point. So it is better the aggregates should be having this more water absorption or less water absorption, you can say. The water absorption should be less, it should not be greater than which one? This is 0.6 percentage, right? It should not be greater than which one? This is 0.6 percentage, you can say, if you just right. Is it right? No. Right? Clear? Actually, in this aggregate impact value also some values are missing. 1 second. This is 156, na? 1 second. In this aggregate impact value, as per IRC we have written, but as per MORTH they have given separate specifications for this actually. 1 sec. I'll add those. Limits of, in that 156 point only I will be writing, right? Because if I write 157, everything will be changing again. So this page number also 3A I will write, okay? So that other page numbers need not change. Okay. So what is that you can say if you just observe limits of this aggregate impact value as per what? MORTH. What is that MORTH? MORTH is nothing but which one? Ministry of Road Transport and Highways. Na? In that aggregate impact only I am writing, right? In that aggregate impact only I am writing, okay? Limits. AAV should not be greater than which one? This is a 27%, right? These values you have to remember, right? Some of the state exams also they have asked this one. There is a possibility, right? For what? For this DBM, right? What is the DBM we have seen if you remember? DBM is nothing but your dense bituminous course, na? For this DBM binder course. For this DBM binder course, and also for which one? This is SDBM, right? Semi-dense bituminous macadam surface course. If semi-dense bituminous macadam is used in the surface course and dense bituminous macadam is used as a binder course, right? What is the binder course? Just below the surface course, that is binder course, na? Below the binder course, will be having this base course or not? Below the binder course, will be having the base course like that. It is DBM surface course. For these two conditions, we have to use this aggregate impact value not greater than 27%. And it should not be greater than 24% for which one? For what? For this bituminous concrete surface. What is the meaning of this surface? Surface means it is used in the surface course or which course? Tell me. It is used in the surface layer or which layer? Tell me. It is used in the surface layer only, no? Sir, note this and tell me. Add this and tell me. In the aggregate impact value, limits of AIV we have written, na? There only we have added these values. Okay? Note this and tell me. Done? Right. Okay. Now, shall I move to the next one? 166th point over. So 167th point you can say. Right. Now, what is that soundness? What is the meaning of this soundness? Tell me. Soundness is nothing but your durability or not, right? Soundness is nothing but which one? This durability you can say, right? So whenever you are testing, that will be testing with which acid if you just observe? This acid solution will be taking, and what is the acid solution if you just observe? That is your Na2SO4 sodium sulfate, or you can also say it as which one? This is magnesium sulfate, na? MgSO4, okay? Sodium sulfate or magnesium sulfate, at which one? This is 105 degrees to which one? This is 110 degrees centigrade, right? So whenever you are testing it like this, right, this will be called as one cycle of testing if you just observe, right? Okay, one cycle of testing, right? So after repeating this process for this 10 cycles, right, you will be having the same weight or you will be having some weight lost. You will be having some weight lost for these aggregates, na? So these are your aggregate particles. Original weight, whatever the weight you are taking before conducting the test, it will be same or it will be lost, definitely. You will be losing some amount of weight, definitely, na? Yes or no? This is your loss of weight after how many cycles if you just observe? Loss of weight after 10 cycles. It should not be greater than which one? This is 12%. When it tested with what? When it tested with what? Magnesium sulfate. And it should not be greater than which one? This is 18% when it's tested with what? That is sodium sulfate, right? Na2SO4 if you just write like that. Got it? That is your soundness test, right? Isn't it? Now, we'll be going for which one? This is shape test. I think almost all tests are over. Shape test and this is stripping value test. If you see, it's over. Whatever we have discussed there in 1.5 hour class, 2 classes, 3 hours, just within 30-35 minutes we are completing. Okay. Shape test and the stripping value. Anything else left? Nothing else left, it seems. Yes, na? Very fastly we did. What is that a flakiness index? A material is a flaky. A particle is flaky when? If what? if the thickness is nothing but your least lateral dimension, if the thickness or this least lateral dimension is lesser than how much, you can say 0.6 times the average size of its group, na 0.6 times the average size of its group, you can say. Okay, now how can you write that flakiness index? That will be measuring using which gauge, you can say, if you just observe, we'll be measuring this flakiness of a material using what, you can say, using this thickness gauge, na? These are the different slots we are having, let us say. Like, so which gauge it is? It is called as your thickness gauge, na? It is called as your thickness gauge, right? Let us say, suppose if it is written here as which one, this 20 to this 15 millimeter and 15 to this 10, you can say, right? This is your 10 to 5, right? Like that, just for an example, right? It is written means what is that we need to understand. On this they will be written, these numbers will be written on this thickness gauge, if you just observe. Have you observed these numbers, everyone? Means from the first slot, which material we have to pass? Tell me. If the numbers are given like this, right, what is that we need to assume? We need to assume that material passing 20 millimeter and retained on this 15 millimeter, right? Material passing 20 millimeter and this retained on this 15 millimeter, right? That we have to pass through this first slot, na? Isn't it? That we have to pass through this first slot, if you just observe, right? That is the meaning of it, right? And what is this thickness we are selecting, if you just observe? What is the thickness of this one? If you are selecting, tell me. What is this thickness of this one? 0.6 times which one? This average size is 17.5, na? Here also, what is its thickness we are selecting? 0.6 times what is the average size? 12.5, right? Like that we are selecting, na? Now, if it is to be flaky material, means thickness will be lesser than that slot opening, you can say. Means the material passing through this gauge will be flaky material, or material which is retained on this will be flaky material. Which one? Tell me. Material passing is flaky or material retained is flaky? Tell me which one. Material passing will become this flaky material, obviously, na? Sir, material passing will become this flaky, you can say, if you just observe, right? So we'll be calculating the flaky material from this material passing. Okay, here how much amount of this material we are passing? Let us say this is your W1 amount. This material we are using in the flakiness index test. Okay, note this and tell me. Correct, Satyam also. Done? Once noted, tell me. I'll move on to this next. That flakiness index definition I'll be writing. Okay. So after passing, right, how much it will be? This is W2. W2 will be retained. W2 will be passing. No? So W2 passing. Let us say, just for an example, right? W2 passing. Right, done? So here 169. So what is that a flakiness index, if you just observe? Which one will be calculating? You can say that is your flakiness index, if you just observe. What is that a flakiness index? You can say that flakiness index will be nothing but your weight passing what? What is that weight passing this thickness gauge, na? Weight passing the thickness gauge, right? Divided by which one? This is the initial weight taken, na? Which weight? that a total initial weight only taken or not? If you just observe that a total initial weight is taken in 200. So how can you write that if you just wanted to write that Fi will be equal to how much weight is passing? You can say W2 weight is passing, original weight is W now. So what is that? How can you write this? That is your W2 by this W1 into 100 na? That is how we'll be getting the flakiness index or not? And it should not be greater than 15% as per which one? This IRC. Okay? As per this IRC you can say, right? Yeah, good morning. Now, what is the next one if you just observe? Elongation. Right here we have mentioned that a particle is flaky when the thickness is lesser than this. Na? A particle is elongated, right? When you can say an aggregate particle is elongated, if you just observe, its length will be higher or length will be lesser? Tell me. A particle is elongated. Under which condition? Tell me. A particle is elongated if its length, right? What is the L? L is nothing but your length on L. Length is greater than how much you can say? 1.8 times what? Average size of its group, na? 1.8 times average size of its group, you can say, if you just observe, right? Now coming to this, which gauge will be using here? Tell me. Which gauge we are using here? Tell me. Which gauge we are using? Tell me here. Length gauge we are using, na? So no, length gauge only we are using, na? There, for identifying the flakiness, thickness gauge we are using, but for identifying this elongation, right, length gauge only we have to use, na? Like these will be having, like these slots will be there, is na? Like that. Now, there if you just observe previously, right, how to pass your material, we have to pass along the thickness direction. We'll try to pass along the thickness direction. Okay, this one how to pass in the length direction, we'll try to pass. Otherwise, if we try to pass in the thickness direction, every particle will pass, na? So we should not go like this, right? We should pass in this manner, right? So these are the slot opening, we try to pass like this. If we try to pass like this, every particle will pass, right? So we should not do like that. We have to pass in this manner. Got it now? Length gauge means we have to pass it along the length only, na? Obviously, this is your length gauge. And now, what are the things written? You can say here it is written as which one? This is a 20 to what? 15. This is written as this a 15 to 10. Let us say this is written as this a 10 to 5, like that, just for an example. Then what is this a slot dimension? We need to take it. This is slot dimension, we have to take it as how much? Is it visible or not? Okay, this is slot dimension, we have to take it as which one? This is 1.8 times the average size of this 20 to 15 group is what? 17.5, isn't it? What is this slot dimension? We have to take it 1.8 times average size of which one? This average size of this 15 to 10 is what? 12.5, right? Like that we have to select, na? Like that we have to select it. Now tell me, which material we have to pass through this? Which material we have to pass through this? Entire W1 again we have to pass through this, or this W1 minus this W2 only we have to pass through this length gauge. W1 minus this W2 only we have to pass through this length gauge, right? And how much is that retained? We have to consider this retained, or we have to consider this passing. Retained is what? W3 amount is retained, and if you just observe, W3 amount is retained, right? Got it? You have to be careful, because if you wanted to identify this longer particle, they should cross this or they should stay on this. They should not cross, then only they will become longer, or not? Then only they will become longer, right? Is that clear? Advanced clear or down? Tell me. Right? Note and tell me. Right, done all of you? Everyone done? Right. So here, next, what is that you can say elongation index, how to calculate here? This is which one? 171 point. Elongation index, right? What is that elongation index? Tell me, EI, how much we have to take it? That is weight passing or weight retained, we have to take it, right? Weight retained, we have to take it now. Weight retained on which gauge? If you just observe, weight retained on this length gauge, na? Weight retained on this length gauge divided by which one? So we have to take which weight? If you just observe, it is a total weight after eliminating what? It is a total weight. We have to mix all the flaky material and again we have to conduct. After eliminating flaky material, we have to do it. After eliminating flaky material, we have to do it. Okay. So already from the first test, flaky material is eliminated, right? So after conducting the first flakiness test, then only we have to come to the elongation test now. Is that no? That is the sequence we have to follow or not? So what is that elongation index? You can say that is your weight retained on this length gauge is how much you can say? W3 is the weight retained on this length gauge, you can say. Divided by what is that you can say? So what is that original weight? W1 minus this W2 now. W1 minus this W2 into which one? This is 100, right? W1 minus this W2 into which one? This is 100, you can say, just got it? Is not? W1 minus this W2, W3 by W1 minus W2 into which one? This is 100, you can say, just and this elongation index should be higher or it should not be higher. That elongation index should not be greater than which one? This is 10 to 15% as per which one? This IRC, na? Right. So which test? Elongation test will be conducted. Elongation test, it will be conducted definitely what? Elongation test will be conducted after what? After which one is over? After flakiness test is over, right? After this flakiness test is over, then only we have to conduct which one? This elongation test, right? So can you conduct both simultaneously or can you conduct this reverse manner? No. First we have to eliminate the flaky material, then we have to find out the longer material or this elongated material, you can say, just observe. Is it? Yes, now? Got it now? Clear this one, elongation index. Next, what is another shape test you will be having? If you just observe, another shape related test will be which one? This angularity test. If you just remember all of you. So if you study this angularity test and this stripping value test, then aggregates over. Bitumen also will start now itself. Okay, because afternoon class now, afternoon 12 o'clock class is there, right? Again, this bitumen wala. In the time that one class may not be sufficient enough to complete the bitumen. Today we'll start up to 9 o'clock we'll take, and today also we'll do little bit of bitumen. Okay. So that in afternoon class we may finish off that bitumen comfortably. It is at 12. It is at 12, not 2. It is at 12. Right. Okay. Any class is there at 12? I think no class now. No class, right? Yeah, then no problem. Great, no classes, right? Because KPSR is also taking 11 to 1 SSC JE class at the time, so no problem, right? Okay. So what is that you can say? If you just observe this angularity number. What is that angularity number? Tell me. So what is the angularity number? If you just observe, this is defined as the voids, right? It is just voids only. It is a percentage voids, right? It is a percentage voids in excess of what? Tell me. Percentage voids in excess of this is 33%, na, right? Why 33%? If you just observe here, what is the reason? If all are spherical particles, if you just observe, right? If all are spherical particles just placed in a compact manner without any other material, then how many voids will come into picture? Tell me. How many voids volume total out of this total volume? So here voids will be equal to this. Voids will be equal to that 33%. And what is that? Solids will be occupying? The solids will be occupying this 67%, right? Isn't it? So suppose if at all, right, what is it you can say? These are all are not round aggregates only, right? These are all round aggregates we are having. But in between this angular shaped particles came into picture. If you just observe, whenever these angular shaped particles came into picture, here more gaps will be created compared to that. So then here what will happen to these voids? Voids will become more than this 33%, na? And what about this solids? It will become, voids will become more than 33%, and this solids will become this lesser than 67%, na? Is that no? Right? Got it? No? Rajendra sir meaning Prime Minister of Engineering. Okay. So here what is that you can say? So voids in excess of 33%, or you can also define it as which one? This is a percentage solids. Percentage solids. Excess means deficit, na? Is that no? In a deficit of how much? 67%, na? Sorry, what does it mean? In deficit of the 67% means how much lesser than 67%? Solid volumes are how much lesser than 67%, or voids volumes are how much greater than this 33%, right? That is the meaning of it, right? Understood? Is not both the ways you can define this angularity number or not? Both the ways we can define this angularity number, you can say, right? Isn't it? Both the ways we can define it as which one? This angularity number, you can say, if you just observe. Then calculation point of view, if you just observe, how can you calculate this angularity number? You can say 173, let us say just for an example, right? That angularity number will be calculated as what? So here if you write it, that angularity number will be equal to, that is your percentage voids minus what? 33, na? And what is that angularity number, you can say? That is 67 minus percentage solid volume, na? Both are same, na? First one is according to the first definition. Excess of 33 means how much more than 33. In deficit of 67 means how much lesser than 67, right? Percentage solid volume, you can say. Okay. How can you get this one, that angularity number? 67 minus, what is the percentage solid volume, you can say? It is your weight of this water divided by which one? This weight of this aggregates into, what is that you can say? Weight of this water by this weight of this aggregates into, what is that you can say, everyone? Into the specific gravity of these aggregates. G means what? Specific gravity is the symbol. Specific gravity of these aggregates into 100, you can say, right? Like that you are having. Got it? This is how we will be getting this angularity number, right? How can you get the weight of this water and all these things? What is the experiment we have to do it? Here, tell me. First one. You take this empty cylinder, right? What is that? That is your W1, na? And you move it to which one? You completely fill it with what? Aggregates, right? Aggregates are completely filled, right? Without any material, right? Without any gap, you try to fill it, right? So then this is your W2, you can say. Okay. Now after that, right, what is it we need to do? Third step, you remove all these aggregates and you fill it completely with which one? This water, na? This is your W3, you can say, if you just observe, right? Isn't it? Completely filled with water. So then in this case, how can you get that angularity number now? 67 minus, right? What is the weight of this water? Tell me. That is your W2 minus this. Did I write reverse? What is it? Did I write reverse? Is it so? Weight of, okay, weight of aggregate by weight of water. Yes, yes, weight of aggregate by weight of water. Correct, correct. Right, weight of aggregate by which one? This weight of water, right? So angularity number angularity number, this calculation. So weight of aggregate by which one? This weight of aggregate by weight of aggregate by which one? This weight of water. Yes, yes, weight of aggregate by weight of water. Correct only. This is reverse now. Yeah. Weight of aggregates divided by this weight of water. Because this should come volume, no? Yes or no? Because weight by this specific gravity will give the volume, yes no? Specific gravity is nothing but your which one? This weight by this volume, no? Specific gravity is nothing but your weight by this volume. Volume, if you wanted to get, you have to take it as which one? This weight by specific gravity. So that way you can remember if you are forgetting like me also, right? By mistake, sometimes mistakes happen, na? Then how to remember this one? Right, like this. It is satisfying that volume definition or not, right? Weight of aggregate by specific gravity of the aggregate, that is satisfying the volume definition or not, we have to check it. Okay, got it now? Right, so angularity number minus by which one? What is the weight of this aggregate? It is W3 now. W3 minus this W1 divided by which one? This weight of water means W2 minus this W1 now, weight of water, into what is it, you can say, into the specific gravity of this aggregates or not, into 100. Now how can you get the specific gravity of this aggregates? Tell me. The specific gravity of these aggregates from this, can you get it or we cannot get it? No, no, no. W1 is the empty weight, na? W1 is this empty weight, you can say. W1, so W, or correct only. Formula I have written correctly. Formula I have written correctly, correct only. W2 minus this W1. So here it is W2 minus this W1 is the weight of aggregate divided by W3 minus W1 will give which one? This weight of this water, na? Weight of this water divided by the specific gravity of this aggregates, you can say. Okay? Okay. Like that will be having. Now tell me, is this a higher angularity number allowed or lesser angularity number allowed? Tell me. Higher angularity number allowed or lesser angularity number allowed? This angularity number will be varying from which one? This is 0 to 11. It should be varying from 0 to 11 only as per IRC. Okay? 0 to 11 only. Right? That is your shape test, you can say. Note this and tell me. So after this, that stripping value, if you write the stripping value, it will be over. Right? 2 more points, 174, 175, aggregates gets over, then we'll start the bitumen today itself. Now itself. So that afternoon class, we can complete the bitumen comfortably. Because more things are there to discuss in bitumen, na? All are theoretical only. Don't tell me. Right done? Okay. So here, what is the next one? You can say if we just establish that is stripping value, right? Stripping value. What is the meaning of this stripping value? You can say stripping value. It should not be greater than which one? This is 5%. No? It should not be greater than which one? This is 5%. No? And it is mainly for which purpose? For using bituminous surface dressing, penetration macadam, bituminous macadam, right? For what? For aggregate used in what? For aggregates used in which activities, you can say? Surface dressing. It is bituminous surface dressing only, no? Bituminous surface dressing, because the stripping value means it is a bitumen removal only, no? Surface dressing. Next, penetration macadam. Next, what else we are having? That bituminous macadam. penetration macadam or this bituminous macadam, you can say, right? So now what is the meaning of this stripping value? Do you remember that test, everyone? So stripping value is nothing but your which one? What is the definition? How can you write the definition of the stripping value? How can I write this? It is a surface area of which one? These aggregates, right? Which aggregates? It is a simple aggregates or it is a bitumen coated aggregates? It is a bitumen coated aggregates, na? Whose, it is a surface area of aggregates. What happens? Whose bitumen is removed? Whose bitumen is removed under which conditions? Tell me. When what? When it is immersed in water, na? When immersed in water, at which temperature? You can say 40 degrees centigrade. For how much time? You can say for 24 hours, na? For this 24 hours, right? So first what you do, you take all these aggregates and coat with the bitumen properly. So every surface, each and every part will be covered fully, right? Then once it gets dried, na, you immerse it in the water at 40 degrees centigrade for 24 hours, right? Then some amount of bitumen will be removed, na? So that bitumen amount of surface with bitumen removal is called as which one? That is your stripping value, right? Now for plastic coated aggregates, right, what is that stripping value? 0, no? For this plastic coated aggregates, right, what is the stripping value? You can say that will be 0, obviously, na? Stripping value will be equal to 0. So this completes your which one out of you? This completes your which one out of you? This completes your aggregate test. Okay, note this and tell me. Clear, everyone? Anything did we miss? I think nothing is missed, it seems. Did we miss anything or no? We did not miss anything, na? Son. Okay, note this and tell me. Then we will move to the next. Done? Okay. Here, this slide itself, I did not thought that we'll be doing bitumen. Okay. Okay. Next we'll be going for which one, you can say? Next we'll be going for which one? This bituminous materials. Okay, this is 11th slide. Are not visible figure? Okay, book type it came. Okay, now understood. This is your 11th slide. Now this is 12th slide, you can say. So highway materials, bituminous materials, right? We'll be doing. Okay. I think compared to plus class, this quick revision itself is going forward. Okay, don't worry. After completing the payment design in that plus classes only, we'll come back to this quick revision of this payment. Yes, that is why you call it as quick, na? Whatever we have discussed in that 70 classes, just we have discussed in which classes, how many classes? Tell me now. This is some 12th class, is na? Yeah, we do live test. Yes, we do live test until that comes nearby. Okay, until that payment design comes nearby, we'll do the live test. Same timing will be there, right? Which day? Which timing? That 7:45 a.m. We'll fix the time so that no problem will occur. Everybody 176. So here, what is that? You can say highway materials bituminous. No? So highway materials, which type of these highway materials will be having? Bituminous materials, you can say. Okay, bituminous materials, you can say. Just how the bitumen is obtained, tell me. Next Sunday take 2 classes per plus. Yes, per plus we'll take 2 classes, right? I'll try to ask them to add again. Bitumen obtained as which one? You are talking about this quick revision 2 classes or plus 2 classes? Plus 2 classes we'll take. Right? Bitumen obtained as what? Highway plus classes is there. Today at 8:30 also the highway plus class is there. Right. So bitumen obtained as which one? This fractional distillation. Okay. Bitumen is obtained as which one? This is a fractional distillation. Na? Fractional distillation of which oil, you can say? Crude oil. So fractional distillation means at which temperature? Tell me. At more than this 370 degrees centigrade. Na? If you remember that, the diagram which I have given in our plus class, right? Bitumen is obtained as a fractional distillation of crude oil as a residue. Na? In all these residuals, it will be obtained. Na? Bitumen is also one of the residue, that black color residue, na? Isn't it? Is that? No. Here, what is that? You can say first one, penetration test on bitumen. So whenever you are doing this penetration test, right, what is that we'll do? Tell me. The last one at this 370 degrees centigrade only, no? Starting with 40 degrees centigrade and we will be going up to this more than 370, 380 degrees centigrade, like that we are going now. Yes or no? So here what is that you can say? This one. This is your bitumen only, na? Yes or no? At which temperature we are conducting this test? That is important. That is 25 degrees centigrade we are conducting the test. And what is that you can say, that a needle will be there here or not? And it is attached with how much weight? Tell me. This needle is attached with how much weight? Tell me. That is your 100 grams weight, na? That is your 100 grams weight. Okay. So here, what is that you can say, that a penetration value? So this is freely falling for how much seconds? Tell me. Free fall for how much time? Tell me. Free fall for this 5 seconds will be allowing, na? This 100 grams weight will be allowed to fall freely for this 5 seconds, right? Isn't it? Now coming to this penetration value, right? What is the penetration value? If you just observe, what is the penetration value? If you just observe, you can say that penetration value will be which one? It is the depth of penetration. It is the depth of penetration of what? Of a needle. Of a needle, which one? Attached with just a needle only. It is attached with some weight, you can say. Needle attached with 100 grams weight, na? Which is attached with 100 grams weight when allowed to fall freely, right? When falls freely for how much time? Tell me. When falls freely for how much time, you can say? Falls freely for this 5 seconds, na? At which temperature? This 25 degrees centigrade, right? Everything gets over now. So, and it is measured in units of which one? How it is measured? Measured in the units of this millimeter, sir. It is measured in the units of this 1/10 of millimeter. Tell me. It is measured in the units of this millimeter only, or it is measured in the units of this 1/10 of millimeter? If you just observe, which units we are which units we are using for this? We are measuring it in terms of which one? This 1/10 of this millimeter. If you just observe, absolutely correct, right? 1/10 of this millimeter only we are using, you can say. Yes, no? Isn't it? 1/10 of this millimeter only we are using, right? Right. Right. Now, so here measured in the units of what? 1/10 of millimeter na? One tenth. So means what is that 1 unit of penetration value? 1 unit of this penetration value will be equal to which one? This 0.1 millimeters or not? 0.1 millimeters, right? So for example, if uh, grade of bitumen is, right, so this penetration value will be using for which purpose? Will be using for this grading purpose or not? Okay, I'll write those points later, right? In the next point, I'll write all of them together. Grading purpose and knowing the softness and hardness, right? All these points I'll be writing. If a grade is, what is that you can say? 60 by this 70. What does it mean? If a grade is 60 by this 70, right? What it means you have to understand? It means penetration value will be what? 60 to 70 units. It is in between 60 to 70 units, or it is also which one? This 6 to 7 millimeter. Na? 60 to 70 units is nothing but your 6 to 7 millimeters only or not? 6 to 7 millimeters only if you just observe, right? Is it right? Is that it? Right? Not this and tell me. Right? Done? Right? Okay. So now 178. So what is the purpose of this penetration test? Tell me. What is the purpose of this penetration value test or penetration test? PV means penetration value, right? What is the purpose of this penetration test? Tell me. It is for grading of this bitumen. Na? It is for which one? This is grading of bitumen, and also for which one? Tell me. And also for which purpose we'll be using it? Tell me if you just observe. And also for which purpose you can say? And also for which purpose you can say? It is to define this hardness or this softness of this bitumen. Na? So no. It is mainly for which purpose you can say? To determine whether it is hard or soft, right? Yes, no? To determine the softness or this hardness of this bitumen, you can say that is very, very important, right? It is mainly to determine this softness or hardness of this bitumen, right? Yes, no? It is mainly to define this, determine this softness or this hardness of this bitumen, you can say just right? Got it? Now, here 179. So generally for that is your 80 by 100 grade is there, right? What is the meaning of this? It is a soft grade or it is a hard grade? Tell me. This is 30 by 40 will be there, and 80 by 100 will be there, right? So that 80 by 100 will be soft grade or this hard grade? Tell me. 30 by 100 will be 30 by 100 will be 30 by 100 will be hard grade. 80 by 80 by 100, sorry, not 30 by 100. 80 by 100 will be which one? This is soft grade bitumen. Na? 80 by 100 will be your soft grade bitumen, you can say, and this is your hard grade bitumen. Na? Second one, penetration is lesser means it is difficult to penetrate, right? Whenever it is difficult to penetrate means more hardness is there for the definitely. Na? So no, more hardness is there for definitely, right? So first one is your soft grade bitumen, and when it is used, if you just observe this soft grade bitumen, soft grade bitumen means, right, when it is used, right, where it is used, it is to be used in the hot climatic conditions or cold climatic conditions, tell me. Ready by hand here, soft grade bitumen we are using in which one? This cold climatic conditions now. Next, second one, this hard grade will be using in this hot climatic conditions, right? No? And 60 by 70 is the grade we are using in which one? 60 by 70, or sometimes it is written as this 50 by 70 also. This is used for what? Tell me. For this normal Indian climatic condition. All are in India only, but general, if nothing is mentioned, but most of the situations will be using that 50 by 70 or 60 by 70. For which one? For normal Indian climatic conditions, right? Got it? For normal Indian climatic conditions, we'll be using this. You can say if you just observe, right? Got it? Now this and tell me, everyone. This is your which one? This is a penetration test and penetration value. Okay. Right, done? Everyone done? Right. So now next one, if you just observe it, what is it we'll be going for? Okay, I'll write here itself. That's 180. Generally, that is specific gravity will be how much? Tell me. What should be the specific gravity generally? That will be 0.97 to what? 0.97 to this 1.02. For which material? Tell me if you just observe. This is for this bitumen. Na? This is for this bitumen. And for this Thor, how much it will be? This is 1.12. What is it you can say? 1.12, that 1.25 for what you can say? This is for this Thor. Na? This is for this Thor. And it is better the bitumen will be having this more water content present in it, or it should not be having this more water content present in it? Tell me. It should not be having this more water content present in it. Na? Shall I write this point here itself? That water content is no. Why? Because if you just observe that bitumen and this water are mixable or immiscible liquids, you can say. Bitumen and this water are mixable or immiscible liquids, you can say if you just observe. These are immiscible liquids, na? So no, these are immiscible liquids, right? That water content should not be greater than which one? This is 0.2%. In the aggregate, how much it was allowed? In the aggregate, how much it was allowed, if you remember? In the aggregate, up to 0.6% it was allowed, na? Is that no? Do you remember this aggregate value? In the aggregate, water content allowed is up to 0.6%. Right? Why water content is present in the aggregates? Because whenever this aggregate is there, some holes are there inside, so they may be absorbing the water. Na? It is not the outside water, it is inside the water only. You have to be careful, right? This water content here, why water will be absorbed? Because the bitumen is of good quality or bitumen is of poor quality, you can say. Because bitumen is of poor quality, this water will be absorbed, you can say. Got it now? Is not? At which temperature we have to heat it, you can say. At which temperature we have to heat it, right? When heated at, right? Heat at which one? 100 degrees centigrade, na? To find. Why? Why we should not heat at higher temperature, tell me? Because if you are heating at this higher temperature, there is a possibility that, right? There is a possibility that this water, this bitumen also may be lost sometimes, na? So, no. Bitumen also may be lost or not sometimes, right? Bitumen also may be lost sometimes, right? Is not? Right, note this and tell me. Clear? Note and tell me. It is done? Okay, okay. Note it, I'll wait, don't worry. Bottom left, water content. Water content should not be greater than 0.2%. Heat at 100 degrees centigrade to find it. That is right side bottom. Heat at 100 degrees centigrade to find it. Okay. Because water will be evaporating at which temperature? Tell me. That water will be evaporating at which temperature? That water will be evaporating only at this 100 degrees centigrade. Na? Will it evaporate at this 30 degree, 40 degree? No. So that is why you are heating at 100 degrees centigrade. Now, generally loss on heating at which temperature? If you just observe at this 163 degrees centigrade for how many hours? You can say 163 degrees centigrade for this 5 hours. It should be higher or it should not be higher? It should not be greater than this 1%. No? Because whenever you are heating the bitumen at this 163 degrees centigrade for 5 hours, now if you are losing means if you are losing some amount of bitumen means it is not a good bitumen, you can say it. If you are losing some bitumen means it is a good bitumen or it is not a good bitumen, you can say it is not a good bitumen, you can say. If you just observe, right? Is it right? Right. Now what is the ductility? If you just observe, what is the ductility test? If you just observe, what is the purpose of this ductility test? This ductility test we'll see and we'll close. Okay, what is the ductility test? It is to measure which property? Tell me. Yes, it is to measure which one? This is elasticity and also which one? Adhesiveness. Na? How much strongly it will be sticking to some other materials, right? Other material means other than aggregate. Na? Other than bitumen means other than bitumen means aggregate will be there or any other material will be there. Okay, right? So this is what you are having, right? How can you define this ductility? This is your ductility test. And what is it you are doing? First of all, here you can say this is your mold will be taking. Na, no? This kind of opening you will be having or not? It will be straight, but okay. Let it be. Let us assume it is straight. Now we will be filling this portion with the bitumen. Na? This opening or this briquette opening, right? We will be filling with this bitumen. Na? This is your briquette. And what is its dimension? Tell me. If you just observe, what is its dimension? You can say. What is its dimension? Tell me. That is your 1 centimeter by this 1 centimeter square shape. Na? 1 centimeter by this 1 centimeter square shape, right? Will be applying this tension or this compression will be applying? Tell me. Will be applying this tension. Na? Will be applying this tension, you can say. Is na? Whenever you are applying this tension, right, what happens? You can say, if you just this will be increasing the length. It will be subjected to increase in length, definitely or not? It will be subjected to which one? This increase in length, you can say it like this. It will happen. Just before breaking, that a thread will be formed of this much size only, na? Isn't it? Thread forms like this, right? Just before it breaks. If you just observe. Once. So now can we say originally this much length only will be there, right? Originally this much length only will be there, and now this is the length extended. Na? So this represents which one? This ductility or not? Can we say this is the increase in length of this one? This is called as your which one? This ductility, right? At which temperature we have to conduct? At this 27 degrees centigrade we have to conduct. And what is the rate of loading? You can say it is your 50 millimeter per this minute. Na? Penetration tested this 25 degrees centigrade. Ductility tested which temperature? The 27 degrees centigrade. You have to be careful. Okay, right? How can you define this the ductility? If you just observe, how can you define this ductility? Tell me. That ductility will be equal to which one? It is the length of this thread or wire formed. Na? It is a length of which one? This is a thread or wire formed just before it breaks, na? Just before it breaks. Okay. Just before it breaks, right? What is the desirable value? Tell me. Measured in which units? Tell me. It is measured in which units? If you just observe, it is measured in centimeters, na? It is measured in this centimeters, right? So it is better that a ductility will be how much? You can say desirable value of this ductility will be how much? You can say everyone, that is your 50 centimeters, right? Desirable value of this ductility will be which one? This more than or equal to that 50 centimeter, na? It is better we should have this more ductility, or it is better we should have this less ductility? Tell me. It is better we should have this more ductility, na? Is that no? Right? Like that. So this is your ductility test. Okay, note this and tell me. Then we'll close after this, right? Remaining tests on the bitumen we'll see in the afternoon 12 o'clock class. Okay, so mostly at 12 p.m. All the tests on the bitumen may be completed. Yes, absolutely. What tell me? While viscosity test is discussed, yeah, actually more expansion is happening means, right? What is it you can say? Before more large thread is created, right? More length of this thread is created means, right? What is it you can say? Actually, I wanted to write those points in the next class. Okay, let it be, no problem. More length is formed without breaking means, what is it you can say? More length is formed without breaking means that ductility, sorry, viscosity will be higher or lesser. Okay, I'll explain after discussing the viscosity. I'll explain the relation between this viscosity, penetration, and this ductility. Right, all the three I'll explain at that time. Okay, all together I'll explain, right? Because I thought of explaining after that only. That's why I did not write those points. Any doubts anywhere? Any doubts anywhere? Clear? Then when is that next class? Today at 12 p.m. we'll be having. Okay, so that we'll be completing the ductility, and payment part will keep hold. After this plus course payment is over, then we'll jump on to this one, you can say. Okay, got it now? Clear? Shall I close the session? Any doubts anywhere? Shall I close? I'll be closing the session. Thank you. Thank you. Have a good day. Thank you. No doubts now? Okay, I'll be closing the session. Thank you. So for every subject we'll do like this only, right? Because surveying is also going on. Surveying but after this highway gets over, then we'll be starting for surveying, right? After surveying, any new subject start, we'll do for that only, right? Like that, for every subject we'll do whatever the plus class we are doing, that quick revision sessions and live tests we'll be doing parallelly in the special and YT classes, so that your subject preparation, PYQ completion, and revision, all the three activities will be completed at a time. Yes, no? That is the intention of doing all this. Okay, thank you. Have a good day.